and today I'm going to discuss to you about basic techniques of integration. Now, in our previous topic, we discussed about antiderivatives, its definition and its examples, and we also discussed some integration formulas. Now, in reality, there are many problems that cannot be solved with formulas. So here, we have basic techniques of integration, although there are many techniques that can be used to solve integral problems. So here, the outline of my presentation. First, I'm going to discuss to you about substitution method, which is the first technique that we're going to discuss. This will be followed by examples and also an exercise. Now, the next technique or the next method is integration by parts, and this will be followed again by examples and also an exercise. So we start with the first technique, which is the substitution method. So a substitution method is also called as U substitution or the reverse chain rule. Now, why is it substitution method is called the reverse chain rule? Because this is a method that is used if we are given this type of expression. That is, we are given an integral of f of g of x times g prime of x dx. As you can see here, f of g of x is a composite function multiplied to the derivative of the innermost function, which is g prime of x. As you can see, this is the formula for finding the derivative using chain rule. Now, in this case, we can let u, which is in terms of x, and that is equal to u is equal to g of x. So we can have this simplified form, which is equal to the integral of f of u du. Now, there are also problems like two algebraic functions, and one of them is not the derivative of the other. So if we can encounter this type of problem, we can also use substitution method. Okay, to understand more on the substitution method, we have here an example. So first example, find the indefinite integral. So the indefinite integral that is given by the integral of the quantity of 1 plus x cubed raised to 7 times x squared dx. Now, by the way, when we say indefinite integral, this is an integral that is expressed without limits and so containing an arbitrary constant. So this is also the reason why we always write or put a letter C at the end of the antiderivative. Okay? So how can we solve this one? Using substitution method, the first thing that we are going to do is to choose our u. What is our u? Our u is a function of x, okay, whose derivative is equal to the remaining function. For example, in this case, we have two functions. This function, first function, and the other one is x squared. Now, we're going to use what is our u, whose derivative is equal to the function that is left. So, for example, u is equal to 1 plus x cubed. Now, getting the derivative of this, the derivative of u with respect to x is equal to 3x squared, right? Now, as you can see, the derivative is related to the function that is left because this can be written as du, which is equal to 3x squared dx. Okay, which implies since 3 is constant, so we can divide this both sides by 3 because it's constant and it's equal to 0. So this becomes du over 3, which is equal to x squared dx. Now, as you can see, the original problem is this one. And we have written du over 3, which is equal to x squared dx. So, moving on, we go back to our u, which is equal to 1 plus x cubed, and du over 3 is equal to x squared dx. So, by substitution, we come up with this equation. The original is this one, 1 plus x cubed raised to 7, and we know that this is our u. So by substitution, we substitute this one here, u raised to 7. And we also write du over 3, which is equal to x squared dx. So in other words, this one is equal to du over 3. Now take note the du over 3 is equal to 1/3 du, right? And 1/3 is constant, so we can write 1/3 outside the integral symbol. So this becomes 1/3 times the integral of u raised to 7 du. Now, as you can see, it is now easy for us to solve the integral of this because this is all in terms of u, right? So, moving on, we come up with this expression. The original is equal to 1/3 times the integral, of u raised to 7 du. Now, the integral of this is simply equal to u raised to 8 over 8 plus c, right? So, if we are going to multiply this 1/3 to this whole expression, so this becomes 1/3 u raised to 8 times 1 times u raised to 8 is u raised to 8. 3 times 8 is 24. That's why we have u raised to 8 over 24. Then 1/3 times c is 1/3 c. But again, since c is constant and 1/3 is constant, so we can use big C to represent that constant 1/3 c. Now, our main problem is to solve the integral or the indefinite integral that is in terms of x. But here we have an expression which is the result of the integration here, but in terms of u. So all we have to do is to substitute our original u, which is in terms of x. So what is our u in terms of x? Our u in terms of x is this one. So we substitute this one to our u, to this u here. So the final answer, since this is our u, so the final answer is 1 over 24 times the quantity of 1 plus x cubed raised to 8 plus c. So this is now our indefinite integral of the given problem. So as you can see, this is how we solve the indefinite integral using substitution method. So if you want to practice more, I have here an example or an exercise. So the exercise is find the indefinite integral, and that is given by this problem. The integral of 15x squared, okay, times the fourth root of 5x cubed plus 4 dx. Okay, so that's the problem. So if you want to answer that, and if you want to show your answer, just comment your answer on the comment section. Thank you once again, and God bless.